Here's problem 920. A 2 kilogram object moving 3 meters per second strikes a 1 kilogram object initially at rest. Immediately after the collision, the 2 kilogram object has a velocity of 1.5 meters per second directed 30 degrees from its initial direction of motion. What is the x component of the velocity of the 1 kilogram object just after the collision? So, we've got mass 1, which is 2 kilograms, moving in the x direction with initial velocity of 3 meters per second in the x direction. About to collide with mass 2, which is 1 kilogram, and the initial velocity in the x direction for it is 0. So this is the way things look like initially. After the collision, we are going to have the first mass moving at 30 degrees from its initial line of action. So we have a 30-degree angle here, moving with a final speed, v1 final, of 1.5 meters per second. And we don't know the angle on the other one. So this is mass 1 up here. Here's mass 2 down here. And V2 final, we don't know. But we do know that momentum will be conserved in any direction we choose. Absolutely any direction. We can choose normally x and y. In this case, we just want to know what is the momentum conserved in the x direction. So we truly are dealing with just components of velocity in the x direction and momentum in the x direction. So our conservation momentum equation will look like this: mass 1 times velocity 1 initial in the x direction plus mass 2 times velocity 2 initial in the x direction should equal mass 1, velocity 1 final in the x direction, plus mass 2, velocity 2 final in the x direction. That's our one equation to rule them all, only dealing with the x directions. Now, our final velocity for mass 1 in the x direction is going to be this component of this velocity being 1.5 meters per second. That's going at a 30-degree angle. So our V1 final x is going to equal V1 final times the cosine of 30 degrees. That's going to be equal to 1.5 times the cosine of 30 degrees, and that is equal to 1.299, so we'll say 1.3 meters per second. Alright, so what does our equation look like now? We got mass 1, which is 2, times velocity 1 initial in the x direction, which is 3, plus mass 2, which is 1, times velocity 2 initial in the x direction, which is 0, is equal to mass 1, which is 2, times velocity 1 final in the x direction, which we just determined to be 1.3, plus mass 2, which is 1, times V2 final in the x direction, which is what we want to find out. We have a bunch of numbers, and we can solve for V2 final in the x direction. So we have 6 plus 0 is equal to 2.6 plus V2 final in the x direction. So V2 final in the x direction is equal to 6 minus 2.6, or 3.4 meters per second. So that is the final velocity of mass 2 in the x direction only.